Hello and welcome to this video tutorial in which you'll learn how to create a simple model with a seating area using the special stands element. This will also help you get started when you're building a model of a stadium. The stands element can be used to model any type of seats. Think of seats in a theater, a small sports stadium with a single stand, or a large oval-shaped stadium with a capacity of more than 50,000 seats. In this video, I will demonstrate how to build the infrastructure and create ingress and egress behavior for a simple model with the stands elements. Stadium seats are often reached via a concourse area behind the stands. Always build a concourse area in a separate height layer from the stands itself using a walkable area. I draw an entry-exit area on the concourse. Later, agents will enter and exit the model from this area. The basic infrastructure of a seating area is added to a model using a stands element. The stands element can be found with 5 other stand elements on the special toolbar. It has properties such as number of rows, aisle width, and seat width. Stands can have 3 basic shapes: a square, a rectangle, or a trapezoid. A rectangle-shaped stand is drawn in the model just like an obstacle. Each seat is visualized by a green rectangle. When an oval-shaped stadium is created, trapezoid-shaped stands are also required. To draw a trapezoid stand, always first draw the corner, which would be at the lower right position if you are facing the stands. Continue to draw the stands in a clockwise direction. I set the concourse layer Z location property to 4 meters and make it transparent and watch the result in 3D. When a stands element is drawn, a stands section element is generated which covers the whole stand. This element contains the seats. The number of seats is calculated automatically. Stand sections can be seen as an activity location at the stands. It also has an activity time property. More sections can be added for visualization purposes or to easily create different scenarios using, for example, the fill rate property. To open its property window, click the stands element and go to the sections page, select the section, and click Open Section GUI. Note, the section also has a group property. On the visualization page, I colored the seats red. The agent should be able to reach all seats from the entry-exit area on the concourse. To achieve this, a stand portal and stand stairs needs to be drawn on the stands. The stand portals can be used by agents to travel between the stands layer and the concourse layer. The stand stairs allow agents to reach the different row of seats. Make sure the stand portal overlaps part of the concourse area. Select the concourse for layer to property. After creating the network, display the walkable space to check that the rows before the seats and the concourse area is all walkable space. Note that not all rows can be reached. Display the medial axes. For 2 rows, the medial axes have a different color indicating a separate network. A second stairs solves the problem. The ingress and egress routes are simple to model. Default entry and exit activities can be used and only a simple stands activity is added. The stands activity has a type stands and a user-defined stands activity is used. This defined logic assigns each new agent efficiently to all seats in all the section based on the fill rate of each section. In most scenarios for stadiums, the number of agents in an ingress and egress generator is based on the number of available seats. Therefore, one can use the predefined stands logic that will take the fill rate of this section into account. For the ingress route, a parameter needs to be changed from 1 to 2 since the stands activity is the second activity in the ingress route. Both the ingress and egress generators are not repeated, and all agents are created at time 0. With these settings for the ingress route, all agents will arrive at time 0, and the sections will be filled one by one. If I make sure the agents already get a section assigned on creation and create an arrival pattern using the delay time property, the agents can be released in the model at a random time, and the sections are also filled randomly. For this, I use the determine final destination logic, which determines the section for the stands activity and spreads the agent entry time in the model over the first 10 minutes. Here you see the 3D simulation of the ingress scenario. And this is the egress scenario. In this video, you have seen how some of the special elements and tools can help you build a seating area and how stands can be used to build a stadium model. Thank you for taking the time to watch this video.